Hey there. So today we're going to be answering this question. The diagram shows a kite. Discuss the measurements you would need to calculate the area A of the kite. Then write a formula for A. Let D1 and D2 denote the diagonals of the kite. So here, as you can see in our picture, it looks like a kite. The diagonal 1 is going to be the vertical line there, and diagonal 2 will be the horizontal line there. So the goal of this is to get an area for the kite. Now I'm going to introduce a little bit of notation here, just to make things stand out a little bit more. I'm going to call the area of the entire kite A with a little kite thing on the bottom there. Yeah, something like that. Okay. So that's going to be the area of the kite in general. Now, there's a fair bit of symmetry here. If you notice, we have two triangles. We have a triangle here, and we have a triangle here. Oh, triangle there and a triangle there. Now, if this was drawn perfectly to scale, the area of the two triangles would be equal. So the way we can rewrite the formula for the area of the kite is we can write that as 2 times the area of the triangle, right? Because if we add up the area for both of them, then that equals the area of the kite. Okay, so we've reduced this problem to find the area of the kite to find the area of the triangle. And the area of the triangle is a pretty familiar one, right? So the area of just on the side here. So let's go up here. So the area of a triangle is 1/2 times the base times the height, right? Okay, now we're only going to be focusing on the triangle up here, the upper triangle, okay? So there, the base is going to be D2, let's go with D2, times the height, and the height is actually going to be 1/2 D1, because D1 is the entire height of both triangles stacked on top of each other, so the height of the upper triangle is 1/2 that. So if we put that together, then the formula for the upper triangle is going to be 1/4 times D1 times D2. All right, so now if we take this and if we plug that back into our original formula, we're going to have 2 times the formula we just have up there, 1/4 times D1 times D2, and this can reduce, so that will reduce there, so we'll have 1/2 times D1 times D2, and that's the area of the kite. All right, so that's one way we could do the problem. There is another way we can do the problem though. So if we take, I'll write this in green. Actually, what color to use? What color? Yeah, I'll do green. Let's see how green works. Okay. Now I'm going to put this kite inside of a rectangle here. Okay, now within this rectangle, we actually have 4 rectangles. So notice how here we have one rectangle here, we have a rectangle here, a rectangle here, and a rectangle here. So we have 4 rectangles. And notice that in each rectangle, the triangles take up exactly half of the area of the rectangle. So here we take up half of the bottom left, here we take up half of the bottom right, and so on and so forth. So from the picture here, we can see that all of the rectangles half of all of the rectangles are covered by different parts of this kite. So if we took the area of the whole square and subtracted the area of the kite, or of the outside parts, well, then we would have the area of the kite. But here, a trick to notice is that the area of this whole square is twice the area of, or the area of this rectangle is twice the area of the kite. Because if we took this part of the kite and copied it, it would fill up this triangle here. If we copied it, it would fill up this. And this triangle here, if we copied it, it would fill up this. And same with this one up here. So that means if we take the area of the entire rectangle and divide it by 2, we will get the area of the kite. So from here, the second way we can do this is the area of the kite is going to be 1/2 the base of the rectangle times the height of the rectangle. And the base of the rectangle is going to be D2, the diagonal 2, so D2, times the height of the rectangle, which is D1. And after a little bit of rearranging, we get the following, which is the same formula as we got doing the first way. So those are two ways we can go about answering the question. In the first case, the measurements in the first way we did it, up here, the measurements we would have need to have solved it were originally just half of D1 and all of D2. In the second way of doing it down here, we would have need to measure all of D1 and all of D2. So I guess it depends on the situation. You could answer the question in different ways. There's also other ways to answer it using the idea of angles, and perhaps we'll answer that in a following video.